So myself Ujjwal Gupta, and I am working as a senior product engineer at SquadStack, which is a SaaS-based talent marketplace for telecalling and sales. Okay, let's quickly jump on to the topic, which is use connection tooling to enable Postgres proxy and to improve database performance. So how many of you ever use connection tooling? Many of you, I think. Okay, so let's discuss today's agenda. So first we will discuss our use case, which is our case study, why we decided to use a connection pooler. Then we will deep dive into how Postgres established connection, and then post that we will check what if we exceed number of connections that will affect database server performance. And after that, we will discuss connection pooling, pros and cons of connection pooling, and some performance benchmarks that we have done for considering connection poolers. Okay, let's move to our case study. Why we decided to use a connection pooler. So, this is our simple architecture. As you can clearly see, we have a single master node which is in one region, and where we have a separate replica in different region, and we have n different servers and n lambdas to access that read replica across regions. So in recent time, we found that there is some sudden spike in resource consumptions due to, so we thought there could be some increment in load. But after analysis, we found that this is not because of load. This is increase in the demand of Lambda executions and servers. So after analysis, we decided to look for a better solution. The second problem we face is security. This is closely related to our architecture. There could be another architecture as well. So we do have restricted servers that don't have that should not have any connection with the read replica or any databases. But as we have VPC peering, then we need to whitelist one VPC with the another. So that could lead into connection leakage. So that is also a problem in our architecture. Third one is network cost overhead that we will discuss in our next slides. Okay, this is before connection pooling, and after connection pooling, we have able to achieve optimized resource usage that we will discuss in our further slides. Then we will fix that security issues by enabling Postgres proxy, and we are able to utilize network cost as well. Okay, so as you can clearly see, now the restricted servers don't have access to our read replica, because we enabled only those servers that have that are in load balancing, which act as a proxy, Postgres proxy. Okay, so let's deep dive into how Postgres established connection. We are talking about what happens when a client requests to a database server. So as you can clearly see, the first step is DNS lookup. The clients look for the DNS name resolution happens. Then the second part is TCP/IP handshaking, which is also a three-way handshaking. The third part is TLS handshake, which is used for authentications and certificates verifications. Fourth is session establishment, and post the session establishment, the authentication and authorization takes place. By authentication or authorization means whether the user is authenticated, has correct credentials or not. By authorization, we mean whether the user have access to that table or schema or database or not. Post that, the queries will be executed and returns the result. And after, at last, they will tear down all those sessions, connection, TCP protocol, etc. So this is totally a tidy process, as you can see. So if we have a multi-region clusters, and if you want to access multi-region replicas, then it can lead into network cost, as you have to perform these number of steps. Now we will look how does the number of connections affect database servers. So as we can see, whenever we create any connection, there is process memory and shared memory comes into the picture. So shared memory is something that is occupied by all the connections, which is shared between all the connection, and that uses caches data, logs, and configurations. And the process manager is something which is private to the connections, which stores states, code, and data structures for those connections. And apart from memory, there will be a small consumption of CPUs as well to maintain state of the connections and for context switchings. So what happens if we increase the amount of connection in our database servers, right? So if we increase our database connection, so that will lead into rapid increase in the server's overall process memory, as process memory is a private memory which is occupied by all the connections. So it will lead into, if we create too much connections within database, that can lead into out of memory errors or performance deteriorations. And it will also impact shared memory, as each process need to share some amount of memory, and if we create too much connection, that will result into high ops and can deteriorate our transactions rate as well. And third, of course, high CPU consumption, as each connection maintains some states and we need to context switch between connections. For this, we perform some benchmarking and tests to validate how it will affect our resources. So for this, we have taken instance of 2 CPUs and 8 cores with 30 GB GP2 storage and 800 connection. And we found that there is a sudden spike in memory, and sudden spike in CPU and variable memory, which is RAM. So which means that if we increase our network connections or database connection, that can cost up to 1.5 MB of RAM to 10 MB of RAM based on your operation, what you are performing. And it can also retard into high CPU usage based on what query you are running at. Okay, so let's discuss about connection pooling. So what is connection pooling? So here is a definition for connection pooling. Connection pooling is a strategy of recycling database connections for multiple requests instead of closing them immediately when a query has been resolved. So basically it acts as a queuing system, or so we can recycle our connection and perform better. Here you can see a clear architecture. Suppose if a client has requested a connection and a connection is available, then it will provide the existing connection, and post that it will send query to client, and client forwarded that query to database. And if there is no connection, then it will create a new connection and will provide then it will execute this query and forward to the database. Okay, so what is the pros and cons of connection pooling? So everything comes with pros and cons. So let's discuss about some pros. So it will improve our performance by reducing connection overhead and reduce context switching. So as we have limited resource, we can limit our resources and reuse our resource, so that will return into improved performance. And there is one more case. Suppose we have a parameter named max connections. So what if we increase, so there could be a chance if we increase the amount of connection, which will return into max connection timeout or max connection exceeds. So that will directly impact our client applications. So to limit those costs, we can limit our resources within connection pooler and a Postgres proxy, so that this problem doesn't occur again. Or third, as I already mentioned, that we can act as an Postgres proxy that I have already shown here. And fourth is scalability. We can reuse connection and scale our systems, so we can by minimizing our resource utilization. And there could be n numbers of pros and cons. Let's discuss about some cons. So it can also lead into latency issues, because this acts as a queuing system. So it can lead into latency issues if not configured properly. There could be different types of pooling strategies: session pooling, transaction pooling, statement pooling. So you have to consider which to use and which to not based on your requirements. Second is connection leaks. So as you already know, there is a Postgres proxy in between. So if any other server or any other client can access that Postgres proxy, which led to connection leaks. So we have to protect, sorry, which which led to connection leaks. So we have to restrict that servers so that only authorized clients or authorized servers can access that Postgres proxy part. And there is also an authentication layer in Postgres proxy that uses user list or the database to protect databases faster to make connections. Third one is increased complexity, of course. So as we are adding another middleware in between a database server and client, so it will increase our complexity. And fourth could be cost as well. As we are implementing more servers for Postgres proxy, then it will result into high cost. Okay, so let's discuss about some performance benchmark that we have done. So we use PG Bench, which is a standard tool for benchmarking Postgres, and a PG Bouncer as a connection pooler. For now, we have took pool size of 50 and client connection with 50. So as you can see, the initial connection time without pooling is 444 milliseconds, and while initial connection time for without pooling is with pooling is 31 millisecond, and the TPS raise is also increased with pooling. So as you can clearly see, it will perform better. But it will not always be true. There could be some other countermeasures as well. Suppose in second example, we can see we have a pool size of 50 and client connection equal to 500. Just for your interest, we are using session pooling here. So as you can see, the TPS is decreased in with pooling. So this can also result into performance issues, as I already mentioned. So connection pooling has both pros and cons. So we have to make sure how we will use this. Okay, this is some metrics that I want to show. Here you can see without pooling there are 500 connections, more than 500 connections, and with pooling there are only 50 connections as we are using a connection pooler. And as we can see, freeable memory drops in without pooling and it backs in with pooling. And CPU utilization is also optimized here. So there are n number of connection poolers in market. PG Bouncer and PG Pool are the two most competitive and mostly used PG poolers now. So yes, here is a minimal difference. We can say difference between PG Bouncer and PG Pool. First, resource consumption. So as we all know, the PG Bouncer is a single threaded, so it is a lightweight solution, and whereas PG Pool 2 is a heavyweight, which uses n parallel connections for each connections. And as PG Bouncer supports multiple types of pooling, it's also a winner in this. High availability, we can we can make PG Bouncer highly available by using some other tools like HA Proxy or something. But there is no inbuilt feature for PG Bouncer to be highly available. But PG Pool 2 supports failover and standby service. Connection timing per user database of pool, we can set connection timing based on per user database of pooling in PG Bouncer. Load balancing is not enabled by default in PG Bouncer, but we can do by using external load balancer or some other tools like HA Proxy, Citus, etc. Management interface, as you can see, there is a separate database that PG Bouncer creates for to draw any insight. We need to log into that database and draw insight. But PG Pool 2 provides a GUI and detailed administration interface. Complexity wise, PG Bouncer is a little bit simple, but PG Pool 2 is more complex than. But there are more tools which are available in the market, like PG Cat and Supervisor, which you can definitely check. Now let's move on to the final conclusion. Connection pooling can lead up to faster response time by reusing connection. It can reduce resource usage. It can improve scalability, and it is simple. But it can also cause latency issues if not configured properly. So thank you. Any questions? Yeah. Yep.
I'll pass on the mic.
Can you go back to your third slide? I think that was the third slide. Yes. Yes, that's the one. So I'm just curious, why don't you use two subnets?
Sorry?
In this architecture,
Yeah.
why aren't you using two subnets instead of connecting it, peering two VPCs? Is there any specific
this is
constraint?
for disaster recovery. This is our architecture. We separate out replica for disaster recovery so we can minimize our RTO and RP.
But suppose for a minute you don't do that. Then if you don't, do you really have to have that?
Yeah. This is our architecture. Each one can have own
No,
architecture.
perfectly fine. You can have lots of architectures, but when I looked at this diagram, first thing I thought is I don't really see a logic for having two separate VPCs. Within the same VPC, you can have two subnets, and then
But
for one of the subnets,
for
you can define.
disaster recovery, we need to set VPCs within multiple regions, right?
Yes, that's how it's written in the textbooks.
Right.
Any other question?
So, what kind of instance you use to run the PG pool?
Normal EC2 Ubuntu instance.
No. So, which family of instance?
Currently, we are using M5 8.x large instance,
Okay.
and there are multiple instances,
So, did
and
you
we have a load balancer.
consider the network traffic overhead, because the PG bounce, the bouncer or the PG pool instance will be doing 2x the network traffic between your application and the database.
But if you can see our architecture, that will be minimal in comparison to cross-region network cost. Yeah.
Hi. So we tried to do a POC on PG Pool 2 like 5 or 6 years ago. I don't remember exactly.
Okay.
So yes, it routes the traffic, the write traffic to the master and the read traffics to the replicas, right? So we use these PGPL SQL functions. Okay. So how you call the function? Select star from my function, right? So, but underneath that function, it had delete statements, and also it was also writing to a particular table called log table, right? So from the PG pool perspective, right, it was a select star. So it looked like a read statement, but
Okay.
underneath it was all the write operations, right?
Okay.
So PG pool was routing the traffic to the replica rather than the master. So our application failed. Okay.
Okay.
Have you come across this problem?
Not
or-
yet, actually. We are
Okay.
using PG bouncer for only read replications, and there is no write replications at all. We haven't faced this issue at all.
Okay. Okay.
One thing I have not seen, probably I might have missed it, the costing aspect of this. How do you see this? As in, have you seen cost increase because of this implementation, or any benefit in terms of trade-offs, the cost versus performance?
There is some cost incurred in this, but we need to ensure security, and this is the architecture to enable DR, right? So there is no other way to enable security and whitelist only those servers that need that access. In our previous architecture, it was a security issues as well. So we need to enable a Postgres proxy. So we are using PG Bouncer as a Postgres proxy more than a connection pooler. So for performance perspectives, we are using master as a read. In case we want more performant queries, we can use masters.
One more thing, probably I shouldn't be asking this, but I think the architecture that you have shown up right here, there might be native solutions available for this architecture as well. Any specific reason you have gone ahead with this PG pool?
No, not sure.
Okay.
So, did you do any sort of comparison with the actual performance. Like here we are facing some sort of network delays. So on the DB side, we have seen we are getting some performance from the graph, but how does the actual performance increase? Because it includes a network delay latency also.
Matlab,
So-
there is a significant improvement performance, but don't have any data for now. Matlab, there is a significant improvement in performance and latency for queries, but we don't have specific data.
So again, coming to the PG pool, how this failover works? So during that failover, is there any loss of the transaction happens?
I'm not sure of how failover works in PG pools. Actually, matlab, you can. I'm not sure.
Okay. Okay. Thank you.
Generally, the recommended architecture is to have a PG pool node or any pooling node in one separate server and the database in the other separate server. So, in case if the PG pool node comes down, what happens to the existing connections which are in the database?
Sorry, can you repeat?
Like in case if the PG pool or PG bouncer node comes down, what happens to the existing connections which are already connected to the database?
So there is some timeout parameters in PG bouncer. So it will automatically terminate those connections which are which are free, idle or free. So there's a parameter within PG pooler. So it will automatically terminate.
What about the active sessions which are running, or if there are like running transactions? Like PG bouncer has 3 transaction pooling or session pooling.
Mm-hmm.
So in that case, if there are active transactions, what happens to those?
Yep. So we are not using for write queries. We are using only for read queries. So we are not sure.
Okay, thank you.
Okay.
Thank you, Ujjwal, for your presentation.